Welcome to the AI Adoption Podcast. My name is Professor Ashley Braganza, and I'm your host. And in this episode, I want to explore the area of energy utilization to run data centers and provide AI services. And who better than to speak to this topic than my guest, Ali Teeney. Ali studied maths at the University of Oxford, and from there, he went on to join the Octopus Energy Group. He was one of their very early employees working in the area of data science. Ali's background is technical, and he has used machine learning to solve a number of problems in the energy sector. For instance, predicting energy demand, designing innovative tariffs, and optimizing battery charging schedules to maximize renewable energy use. Octopus transferred Ali to Tokyo to set up their data science team, not just for Japan, but the whole of the Asia-Pacific region. And using that experience, Ali transitioned to Kraken, which is Octopus Energy's technology arm, to set up and lead their AI team. And this team have had a number of successes because they were pioneers in the use of LLMs. And when you think back to ChatGPT being launched in November of 22, by January 23, they had applications based on LLMs, and they continue to develop, in Ali's words, technologies at the bleeding edge. Ali believes that Kraken has proven that AI can be a win-win for customers and for companies, and that AI will help to build better energy systems. For instance, a renewable grid that is cheaper, more reliable, and easier for their customers to use. And that must be a welcome development. So Ali, welcome to the AI Adoption Podcast. Ali, I've told the audience a little bit about you, but perhaps you could say a little bit more about yourself and also about Octopus Energy and Kraken.
Absolutely. So I'm sure lots of people listening will be aware of Octopus now. The biggest supplier of energy to homes in the UK. But Octopus is a company with many tentacles. For example, we have retail businesses, not just in the UK, but around Europe, in Japan, in the States, in New Zealand. So really a kind of global presence now. But also many other interests in the renewable energy space. So, from owning and investing in renewables directly, to our services business, people going and installing things like smart meters and heat pumps and solar panels on people's roofs, as well as the tech arm, Kraken, which is who I work for now. So Kraken is really the operating system for utilities of the future. So we built it in-house at Octopus Energy, which was always the plan. The Octopus Energy team was a team of technologists who always were wanting to build software to make energy better, basically. So we built it at Octopus, and really it was one of the big things that enabled Octopus's rise. And now, in fact, we license that software to other companies in energy. So, one way or another, I think 50% of UK households are powered by Kraken now, either via Octopus or via companies like E.ON and EDF who use Kraken, and as well around the globe. So I think we've got something like 10 countries and counting. So a really global footprint as well for Kraken, serving both retailers like Octopus, but as well distributors, vertically integrated grids. We've got a big arm that's looking at flexibility, both at the kind of home and kind of grid scale stages. So to put it simply, the Kraken mission is to accelerate the green transition using technology and to bring affordable renewable energy to the world. In terms of my story, I studied maths at uni and was always into kind of maths and computing and stuff. So I joined Octopus. Well, as it was then, there was only Octopus, so I joined as an early employee. I think there was 50 or something of us. And so naturally, as an early employee in a business like that, I had my fingers in lots of kind of data science related pies around the business. So things like understanding the cost of energy and helping to design tariffs, predicting demand, optimizing battery schedules for homes with batteries and solar panels and things like that, as well as, really customer focused stuff about understanding why and when customers were going to contact us.
Great. Thank you for that. Thank you for that introduction, both to Octopus and yourself. I'd like to kind of get started in terms of this conversation with AI adoption and energy. And clearly, there's an awful lot of talk, and there are a number of reports about the extent to which energy is going to be needed and consumed by AI systems. So for the listeners, just tell us about what is meant by the AI energy challenge.
Well, I guess there's, the big thing, I think probably the topic of what we'll be talking about mostly today is fairly simply, how do we power the data centers that we require to train AI models, simply put. And we can kind of dive into the specifics of why that's a problem and what might need to be done there. I think it's, to do with the location of data centers, to do with powering them renewably rather than using fossil fuels. But as well as that, I think that AI is an opportunity for energy. We can build a better grid, an energy system that's more renewable, that's cheaper, that's more reliable, that works better for customers using AI. And I think there's a lot of opportunity for that, whether it's controlling assets to balance the grid and predict usage, things like that. Octopus Energy, for example, is using Kraken to shift, I think, 5 gigawatt hours of usage per day. That's split between kind of home assets and grid scale batteries and things like that. And as well, there's a challenge about kind of bringing customers along with the journey. And I say that because energy is actually getting significantly more complicated, not less complicated through time. 10 years ago, you'd have 1 meter reading every month, if that, right? And now we've got smart meters that give you 48 every single day. And you've got innovative tariffs that change price throughout the day, and assets in the home being controlled, etc. To let customers understand that and to build trust in the customer, if a retailer is going to control your battery, for example, you need to trust them, right?
Yeah.
And so there's a big opportunity for AI there in terms of helping the customer, making it more understandable, building trust, which I think is going to be really important with the renewable transition.
I think this issue of trust is really important, not just for energy, but for AI generally. But what do you see as being the major challenges for the energy sector in providing sufficient power for AI going forward?
Well, I guess, like, to put it simply, data centers use a lot of power, right? And the training workloads that AI requires, these are kind of like massive supercomputers. They use a lot of power, and it's localized in one place. So, maybe to put that into context, OpenAI's recent project Stargate, which aims to build a number of massive data centers in the States, we're talking like 1 gigawatt per data center there, and I think they're planning 16 or something like that. The XAI, so Elon Musk's AI company, has built a data center that I think is 0.5 gigawatt in Texas. These are massive projects and massive usage, really stepping up the energy sizing of data centers in the past. And I think that, like, it's maybe worth just pointing out at this stage that there's kind of two maybe workloads when it comes to AI, and specifically when we're thinking about data centers. There's training, and then there's inference. So training is basically the process of creating a new model, whereas inference is the process of actually using it downstream. And there's quite a big difference between the two in terms of the demand on the data center. So first of all, there's inference, right? Using it when you're interacting with ChatGPT, for example,
Yes.
it's doing inference, right? And that in terms of the energy usage there, you'll see quotes like an inference call is 10 times as much as a Google search in terms of the
Yeah.
energy usage. I think it's like 3 watt hours instead of zero point 0.3. And on one hand, that sounds like a lot. Um, on another, on the other hand, I think it sounds like not that much. We all Google things without even thinking, right? You don't even
Yes.
consider the energy cost of a Google search. And often, if you're using ChatGPT, you might save 10 Google searches anyway. It's like maybe the energy usage of streaming TikTok for a few minutes, which again we do without even thinking about it.
Yeah.
Now, there's some subtlety here because we're moving to this era of so-called test time compute, which you might have heard of, which puts a bit more pressure on the inference side. But largely, inference models, I think, will see they're the most innovation in terms of like how they're optimized, how they're distilled into smaller models. We see them running on the edge, on the end user's device, and things like that. So while it's a significant kind of change in the way that we use the internet, we're not talking about massive loads here, right? We're talking about, in terms of the internet's total power draw, if we moved all of our searches from Google to ChatGPT,
Mhm.
be talking like 1% of the total internet's power draw. And internet usage already grows by several percent a year. So
Yeah.
it's not outside the realms of normality. Whereas training is quite different. I think last estimate I saw that GPT-4 was something like 50 gigawatt hours to train. Um, there's a lot of figures floating around about
Mhm.
how efficient models like DeepSeek are. It's very difficult to get a real sense of how they trained it, but conservatively, it might be something like half of that. And that doesn't include as well the experimentation required, the failed training runs that go into training these models. So the AI training load is significant. So I think various predictions put the expected energy increase total in terms of the total system usage for data centers to go from like 1 to 3% of the total energy usage, the total generation, right?
Yeah.
And in one sense, that isn't massive compared to other energy intensive industries, but it has a couple of things that are specific about it. For example, one, it's incredibly localized, right? We want a big fat training center of a gigawatt, let's say in the Stargate project, and we need
Mhm.
to power that, right? And we want to do it renewably.
How, I mean, you mentioned DeepSeek, and clearly the DeepSeek came out of caught the markets and caught some of the other tech companies kind of on the back foot. But do you see other developments like that which are likely to reduce the amount of energy that may be required by some of these AI systems?
I think that like you know the there's a relentless march towards more efficiency, especially on the inference side.
Yeah.
Um, and you see techniques coming all the time around how to distill things, how to optimize the workloads on, even at the chip level. There's a lot of really impressive work done by the DeepSeek team where they went really down to the kind of bare metal of the chips to optimize how things were working. So, I think we can expect significant improvements to the way these models are are used in inference and probably in training as well. The the flip side of that is, especially on the training side, if we can train more efficiently, typically the result is to train more, right? Rather than, stop early,
Yeah.
as it were. There is some subtlety again there around whether with the current uh, era of models, we're coming to there's basically two bounds at play with a model training. There's the energy cost, essentially, and there's the amount of data you put into it.
Yeah.
And so what we've seen up till now is that both of these things are increasing together, right? There's a question about whether we're starting to come to the end of the amount of data that is made available for these models to train.
Ali, the AI action plan, has a whole section about growing the number of data centers and AI zones across the UK. And I just wondered, what do you think are some of the choices that policymakers have to kind of make to deal with the energy requirements for AI?
Absolutely. I think there's a lot to do when it comes to policy for energy, especially thinking about AI data centers. So, if you're thinking about a place to build a data center, there's a couple of things that you have to think about, right? There's the location, there's how to power it, and then there's the policy that we can make to try to make that easier. Now, first of all, on location, thinking about that difference between training workloads and inference workloads.
Yeah.
The other big difference is that an inference workload is connected to the internet, right? It needs to be fast, right? It needs to have extremely good connection to the internet, low latency, right? Whereas training workloads don't require that so much, so they're much freer in terms of location. And in fact, preferably you build it where it's cheap, essentially, right? You're going to use a bunch of land and you want it to be cheap. Now, there's a very similar problem with renewables in the sense that renewables are not very energy dense compared to fossil fuels. And so again, we prefer to build them in places where the land is cheap, essentially. And as of course, where there's actually renewable, wind or sun, for example. And that can be a problem for renewables because that's typically far away from population centers where the energy is being used. So it comes with an associated transmission problem.
Yeah.
If we can co-locate these things, an AI training center and renewables, then they're a match made in heaven. And that's, not even to think about the possibilities for using data centers as a flexible demand, because in some ways, training a large language model, that's a long training run is a perfect example of a kind of batch job that could be spun up and down depending on demand. So
Yes.
these two things could be married very well if we can make it work. So I think that in terms of the policy, essentially there's a couple of things. Number one is that we need to be able to incentivize that industry near renewables, right? And that is essentially a question of price, right? And we need it to be easier to connect new renewables if we need to build to power these things. So, I guess as an example, because of lack of transmission capacity, Scotland curtailed enough wind last year to power something like 5 megascale data centers with AI. Not only did they curtail it, but we paid them to do it as well. And if we can incentivize people to build in a place that's co-located with renewables already, then we can use those data centers to eat that demand to help to balance the grid there, right? The problem, I think, is that there's stiff competition in terms of price. I think in the UK, typically, you'd be looking at something like 20 to 25 pence per kilowatt hour to power these things off the grid. Compare that to Nordic countries, is literally 3 times cheaper. We're above the average in the UK compared to other countries. And so if you're if you're building a data center, for example, Microsoft, they have their kind of second flagship data center. They've got one in the eastern states. Their second is in Sweden because they've got access to renewables that are very cheap there. And it gives them a foothold in the EU, which is quite useful for things like GDPR, etc., and working with European countries. Now, Sweden has zonal pricing, which means that we can, you can build a data center near to renewables and power it cheaply. And in fact, Microsoft Data Center has like fully time matched power by renewables. So, to put it simply, I don't think the UK's current offering will cut it if you're a data center operator. Thinking about building in Europe, say, it's just too expensive, and we need market reform in terms of how we price energy to incentivize building data centers in places where the energy is cheap. And we need reform of how to actually build new renewables faster than we are now, basically.
I mean, one of the great things of having someone who's an expert in the field is I can ask silly questions because I don't know. So, but why is there this big price difference then between, say, Sweden and here?
I mean, like to put it simply, so there's obviously a load of factors at play. One of the reasons why Nordic countries can be attractive is because they've got a lot of hydro,
Okay,
which is obviously great.
yeah,
I mean, it depends heavily on your geography, right? You can't just build more hydro. But if you look at Nordic countries as well, they have zonal pricing, which means that they can adjust the price of energy depending on the pressure in a specific region. Now, if you look at the UK, we've got loads of wind power in Scotland,
yes,
and essentially the issue is that we don't have enough transmission to transport that to areas, for example, in the south, where we could use it. And the market structure is set up in such a way that the price for the UK, the price for energy in the UK is set across the whole kind of grid, across the whole country, on the most expensive kind of marginal cost of energy, basically
yes,
for that half hour, say, which is almost always if we need to use uh, fossil fuels, it's fossil fuels, right? Because the price of renewables is marginal cost of energy for renewables is very low. But that means that if you're building a wind farm, you're incentivized to build it in Scotland because there's a lot of wind there,
yeah,
despite the fact that it's not actually useful there today because there isn't the transmission capacity to take it south. And so we spend, I mean, in the winter this year, on a bad day, we were spending something like 10 million a day to curtail wind, both in terms of direct payments to wind producers to ask them to turn off, as well as the cost of then regenerating that with fossil fuels in the south. And so we basically have a system it's built for a world where we have, relatively few large generation, plants,
hmm
and we're distributing that across homes in the UK. We're moving, and we have moved into a new world now where we have generation at much smaller scales in many more places, right? And that it's the generation that is uncontrollable rather than the demand. Whereas in the past, if everyone was going to put their kettle on in the halftime of a football game,
yes.
we'd put more coal into the fire, right? So it's really a system built for a different time, right?
And it's interesting because the government has clearly got its eye on kind of, becoming carbon neutral, for the UK to become carbon neutral. The green agenda is still very strong, and pursuing, the UK's green credentials is still a priority as for the government. And I just wondered, how is this expansion of into data centers and creating these data centers going to impact on that green agenda? Do you think, Ali?
Well, of course, like the it if we do it wrong, then it would be really bad. I think if you look at, for example, XAI's data center, I think it's called Colossus in the States, in
Hmm
Texas, I think, might be wrong. Um, they power that with gas turbines, basically
Okay.
small gas generators, and that's unregulated as long as they're not in the same place for more than 364 days. So they basically shuffle these things around every year to avoid it being regulated. If we don't do it properly, then we'll end up in a world where we basically start burning way more fossil fuels in order to build data centers, which would be terrible.
Yeah.
But we don't have to do that. And in fact, I think that, you know, it's another example of us trying to increase the electricity demand, basically. And we're already doing that, in fact, when it comes to, we're trying to, uh, uh, we're trying to transition away from fossil fuels in transport using EVs. We're trying to move away from fossil fuels in heating homes
hmm
by moving to heat pumps, right? Both of
Yes.
these things, are electrification, right? So electrification in and of itself is not a bad thing for the climate. And in fact, if we can build a grid that is extremely renewable and is running on renewables, then it's only a good thing. So I think that there's a way to do it. We just have to make sure that we have a system that's set up so that data centers can be run cheaply using renewables, basically. And I think it's probably worth saying as well that there's a flywheel effect here, right? If we can do AI well, it's not just the data centers that need powering that's contributing to the transition,
Yeah.
but there's a massive effect on the rest of the economy, both directly in terms of using AI to help optimize the grid, for example.
Mm-hmm.
But as well, even indirectly, if we have AI that's helping material scientists build better photovoltaics, then we get this flywheel effect. So I think that there's not it's a big opportunity, basically.
So, looking forward, I mean, do you think the UK can ever achieve genuine green AI?
The short answer is yes, absolutely. I mean, look at the data centers from companies like Microsoft are already committed to building data centers that have full time matched renewables. There's big movements from these companies themselves about how to do this stuff green and what the credentials should look like. There's currently a bit of a fight going on between Microsoft and Google versus kind of Meta and Amazon about the specifics of how to certify a data center as being green. And I think Microsoft and Google's approach is much better, that looks specifically at location and time to make sure that almost every electron that's going in can be tracked back to a renewable source. As long as we embrace renewables, we embrace zonal pricing, so that we can build data centers in the places where we need demand. And we can use extra renewables, then it can be a boon.
What opportunities do you see for Octopus in this as this AI and energy need evolves?
Well, I think that Octopus is in a fantastic position already as a trailblazer. We talked a bit about trust before. Customers are already happy to let Octopus kind of control their assets and optimize the grid. Customers love Octopus for things like the agile tariff, which is a tariff that changes price every half hour throughout the day.
Yeah.
The received wisdom from the industry when we were making that tariff was that customers don't react to time of use of tariffs like that. And what we found was that people shift their usage significantly. And I think a lot of that was to do with the way that customers interact with Octopus compared to the way that customers interact with other utilities. I mean, put simply, Octopus is beloved in an industry that's known for being hated, basically. So I think there's a lot of opportunity there for Octopus, as well as working directly with data centers to try to power these things. For Kraken as well, I think that we touch all aspects of the grid already, and one of the kind of powers of Gen AI is its ability to take data from many different places, i.e., unstructured data, into one place and understand it and take action off the back of it. So Kraken's kind of breadth of data for and about the customer in one place has long been a competitive advantage for Kraken for many reasons. But I think AI is going to actually widen that gap in terms of what we can do with it.
Yeah. And I guess you have direct contact with customers, consumers, and at the end of the day, it's the consumers that are very often using some of these AI applications. Do you see that there is a need to almost understand what's happening at a societal level, so that people are perhaps a little more thoughtful before they type something into a Google search or type something into a large language model for a search? In other words, do we need to maybe start thinking about how consumers use AI to to kind of minimize the energy consumption? Do consumers need to think about their AI energy footprint?
It's a good question. I suppose I think that there's two ways you can come at this. One is if you think about, for example, things like agile, consumers often are happy to change their behavior,
Yeah.
if it's going to benefit the climate, right? That's one of the things that I think we've proven at Octopus. On the other hand, I think that we do a lot of work to try to take things off people's hands. For example, Octopus has a product that's backed by Kraken technology called Intelligent Octopus, which is basically a way for consumers to plug in their EV and maybe their heat pump and set some kind of like preferences and leave it to Octopus to deal with it.
Yeah.
And so the example might be the customer plugging in their car when they get home from work, and they basically say, I want it to be full, or want it to be 80% full by 7 a.m. when I leave for work. Whenever you do it, it's up to you. That's really beneficial for us because we can use computers and AI, right, to decide the best time to charge. We're coming at it from both sides. I think we have to simultaneously try and take as much off people's plates. And when it comes to AI, I think that means looking at things like like batch workloads, a lot of stuff that there's been a lot of moves from big players like foundation model providers like OpenAI and Anthropic and etc. to provide options to do things in batch. And really what's happening behind the scenes is that they're waiting for the correct moment.
Yeah.
I think we can do that. That's almost like the automated version. And then on the customer side, I think that there's a delicate balance here. If we push too hard and say, don't use ChatGPT between these hours or whatever, then I think it's going to be counterproductive. If you think about it in terms of comparing it to a Google search, I don't think that we would be worrying too much about, the energy use of a Google search or sitting on TikTok for 3 minutes. So in some way, that I think that especially when considered over the whole grid or the whole country, will balance out. I think it's a challenge for generators, and it's a challenge for the grid to try to make sure that we can meet that demand in a sustainable way, which is very possible.
Well, that's on that very optimistic note. And let me just say a huge thank you to you, Ali, for taking the time to join the AI Adoption Podcast. You've provided some incredible insights. I've certainly learned much more about the whole need to balance not just the generation, but also the transmission of energy, which I think is an incredible challenge, particularly for regulators and the government, I think, to move this forward. So thank you so much for joining us today, and I look forward to seeing you soon.
Thank you very much. Thanks for having me.
All the best.